Okay, so to continue with chapter 12 and how to determine the units for K, just kind of very quickly, this won't take very long, but I was running out of time on the last one. So I typed it, so I can't write on a smartboard, but just looking at, remember rate, we said in the beginning of the last screencast, should be in molarity per second always. So what should the units of K be so that you always end up with a rate of molarity per second? So looking at a zero order, so rate, that's got to be in molarity per second, equals K will be some number, 5, 16, 1.6 times 10 to the negative 23rd. It's a number, and it's got to have units with it. And then this is always in brackets, it stands for molarity. So we need to figure out what are the units of K. Well, if it's a zero order reaction overall, anything raised to the zero power we know would be 1. So this whole concentration of A piece goes away, doesn't matter. So then K has to take on the units of molarity per second because that's all that's left, since you know this has to be molarity per second. If you look at a first order reaction, then rate has to be molarity per second equals K times A, which is molarity always, raised to the first power. Well, something raised to the first power is just going to be itself, so this stays as molarity. And then K would take on the units of 1 over S to give you that molarity per second that you need to have for rate. So I'm going to let you think about, for second order reactions, if rate has to be molarity per second and A is molarity always in brackets, and it's squared, so you have molarity squared, what would K have to be so that it would cancel out or add to whatever your A is so that you end up with molarity per second? And then how about third order? What would K have to be if you had A cubed? So I'd like you to come tomorrow with those two questions answered to show me that you understand how you get K. So if I told you then, ultimately, if I gave you K and said the constant is measured the constant is 5 molarity per second, then you would automatically be able to tell me, oh, if K is molarity per second, then we must be dealing with a zero order reaction. Or if I said to you, K should be 1 over S, or inverse seconds, then you would say, oh, we must be dealing with a first order reaction. So it's kind of helpful to know what K's units are because you can determine what order the reaction is. So that is the end of this podcast, nice and short.